Hi guys, so in this video we are going to discuss a new question, maximum width of binary tree. So first I will tell you what is this question. This question is like if you are given 1, 2, 3, 4, okay, 5, 6 and 7. So what you would have thought is that I will check width of this level and I will say that okay, this level 0 has only one node, so size of this level is 1. Then you will say okay, this level 1 has only two nodes, right? So I will say size of this level is equals to 2. This has three nodes, this level has three nodes, so I will say that level 2 is having three nodes. So I will increase it to 3, and I will again say that okay, it is I can't update it, so it will be 3 only. So I will say that 3 is my answer because maximum number of nodes which I could get is 3 in every level. But this means what you just thought is something which is very easy and can be done easily by level order traversal. But in this question they are basically saying that you should include the null nodes as well. For example, we have a null node here, right? And null node lies between two not null nodes like 5 and 6 or 4 and 6. So I will say that this level's size should be 4. Okay, this level's size, level 0, level 1, level 2, so level 2's size should be 4. So you will say okay, not a big deal. I mean, I can just simply keep on adding null to my level order traversal, and I will simply check the size of that level and I will return it. So it is not that simple. Why? Because I will be having null, here I will be having null, here I will be having null, here also I will be having null. So you can't just simply say that size of the level is size of the size of this is size of the level. Okay, because uh, this level 3 size is actually 1, because these null nodes, their left is not a not null node, but their right, there is nothing, there is no not null node in their right. So what I told is that this null should be enclosed between two not null nodes like 4 and 6, and this is not the case for any of the null nodes here. So I will say that I can't consider any of the nodes here, so size of this level is 1. Okay, so how will we proceed this question? Is there any other approach? So I was unable to solve this question on my own, so I referred a YouTube video. In that YouTube video, how he taught was like, I am drawing the same tree again. It was like this only, I believe. And yep. So how he did was like, he said the starting index is 0. Then he said the starting index of this is 1. This is 2. And then it's like indexing it like this. And this will be 3, this will be 4. The null will be of 5. This will be 6. And this will be 7 if something present, so it will be 7, it will be 8, this will be 9, this will be 10, and this will be 11, 12, 13, 14. Okay, if some nodes will be present, so there its index will be 14. So how will we calculate? I will say that okay, the first index is 0, okay, and the last index in this level is also 0. So the first index, I will say the leftmost index, I will use lx to represent that, the leftmost index. Why I'm writing x? Because uh, in the vertical, in the same vertical I am traveling, so I am writing x. You can write any other variable, I just wrote x. So leftmost, I should have better written rightmost and leftmost. So 0 minus 0 is equals to what? Is equals to 0. Just add 1 to it because it's a one node, right? So the size of this level is 1 according to this logic. And now I will be using the same thing, rx minus lx. Rx was the leftmost node in that level, and Rx is the rightmost node in that level, and Lx is the leftmost node in that level. So let me use that same logic again. So leftmost node will be this, which is 1. So 1, and rightmost node in this level is 2. So 1 minus 2 is equals to 1, but I will be adding 1 to it, so it becomes 2. So yeah, again for this level is equals to level 1, I am getting answer 2, which is correct. So let us check level 2. This is level 0. So the leftmost node here is 3. Index is 3, right? So I will say okay, 3. And rightmost is this, yes, 6. So I will say 6 minus 3. 6 minus 3 is 3 only, right? And I will add 1 to it, so it becomes 4. So 1, 2, 3. Since null is enclosed between 4 and 6, so I will consider it as node. So 3 and 4. So yep, 4 is my answer. So it holds true for this as well. Now I have only one more node to check. Let us check that also. So this is not a node, this is not a node. And 7, yep, 7, when I push it out from my queue, I will say that okay, your index is 9, right? So this is my leftmost index, which is 7, and I will say that this is my rightmost index also. And as we proceed, I will say that okay, if I find an index which is more than 7, which means that it will be uh, the rightmost index will be definitely, the right node will be having bigger index than 7, right? So I will re-update that, I will update that, I will update 7 to that index. So since then I went to this thing, but there is nothing here, nothing here, nothing here, nothing here. So I will say 7 minus 7 is equals to 0, and 0 plus 1 is equals to 1. So I will say that L3 is equals to 1, and this also holds correct. So basically this logic of Rx minus Lx and indexing the complete tree works. But how will you know that this 7 here, its index should be 9? This is the question. So for that we have a formula: 1, 2, 3, 4, 5, and 6 was where, I think here, and 7 here. So this is 0, right? This is 0, and since the index is keeping on increasing, so what I will do, I will say that its index should be 0, its index should be 1. So I will say two times of this index, and I will say it 2 times of this index plus 1. So it will be 2 into 0 plus 1, which is equals to 1 only. 2 into 0, which is equals to 0 only. So this node's index will be 0, and this node index will be 1. Okay. Now what I will do is 0. I mean, this is 0, right? So I will say 2n. 2n will say that okay, 2 into 0 is equals to 0 only. 2 into 0 plus 1 is equals to 1 only. Then this is what? 1. So I will say that 2 into 1 plus 1 is equals to 3. Okay. So I will say that my Rx is equals to 3 and my Lx is equals to 0. So Lx minus Rx will be 3 minus 0 is equals to 3, and 3 plus 1 is equals to 4. So 4 are the total number of nodes in this level, and that is true also, right? Because the null here is somewhere in between it. So indexing works. This should be the third index and this is the third index. I'm not doing like 1 then 2 3 4 5 6 7, because look at 3 and just look at 7. So 7 is a pretty huge number, right? So I want my numbers to get fit in int range only. Otherwise their value will be increasing exponentially. So the first node of every index I am making it 0. Okay, then what about 7? The seventh index will be 2n plus 1, which is 2 into 1 plus 1, which will be 3. Okay, so seventh index will be 3. So Rx minus Lx is also 3, Rx is also 3. So 3 minus 3 is 0, and 0 plus 1 is 1. So total number of nodes in this level are 1. It is correct. But uh, I want you to know something, and it's that if it's 3 here, okay, if it's 3 here, so I don't want it to be 3, I want it to be 0. If it's the first node in every level, I want it to be 0. So what I will do, I will just subtract it from itself. What I am saying that I will subtract it from itself. Why will I do that? I am doing that because just see that if 7 had some children, okay, 7 had some children, for example, it will be having 8 here, it will be having 9 here. So what will be the value of 9? You know, the 9 value will be 2n plus 1, and 2 into seventh index is 3, so 2 into 3 plus 1, which is basically 7. So ninth index will be 7. Ninth index will be 7, and it could be 2 also. That could be 2 also. So I want ninth index to be 2, not as 7. I want 8 index to be 6, not as I want 8 index to be 0, not 6. So what I will do, I will just subtract 6 from 8th index also, 6 from ninth index also. So basically I am shifting whole thing left. If 8 was here, 9 was here, and 0 was here, so I will shift both things here by subtracting the index value of 8, so that 8 also comes back 6 times. How much? Yeah, 6 times. And 9 also comes back 6 times. So 8th new index will become 0, ninth new index will become 1. So it will not change the answer, but um, you got the point, right? If I am having 7 here, then if I do 2n, if I am at this some seventh index, and if I do 2n, so it becomes 2 into 7 plus 2 into 7, which is 14, and this becomes 15. And then this 14 will become what? 14 into 2, 14 into 2 plus 1, 14 into 2, which is what, 28, and this will be 29. Then 28 will be 2 into 28 plus 1, and it will be 2 into 28, which is 56. Then 56 children will be 2 into 56. So this will be 108, right? 108. So as you see that here it was 7. In the next level it become 14. Next level it went to some 28, 29, and in the next level, just 4 levels down, it becomes 108, from 7 to 108. And it could have been like, if I subtracted, if 14 was, if this index means 14th index was the first node in that level, so I could have subtracted 14 from both of them, and it will be something like 0, and this will be something like 1. So I could have done then 0 into 2, and it will be 0 only. 0 into 2 plus 1, so it will be 1 only. Okay, so then 0 into 2, so it will be again 0, and again doing 0, 2 into 0, so it will be again become 0. So in that case, in the end also it's something 0. So 108 is smaller number or 0 is smaller number? So 0 is smaller number, so I will do this thing. Do this thing means remove, I will subtract the index of the first node from every node in that level, such that if the range was like here, means uh, some node 1 of that index is here, node 2 is here, node 3 is here, here we have 0. So I will subtract, for example it was 7, so I will subtract 7 from all of them, 7 from all of them, such that it becomes something like this. Means basically it shifted backwards. Okay, so that we don't make it a very large number like 108, but a small number like 0, or some small number, so that it is always in a range which we can handle. So I think uh, you got basically what I wanted to say. So max width in every level will be 1, since there should be at least one node, right? So I can expect at least one node. If root is equals to null, which means return 0, basically no node. And in our queue, in my queue, I am storing root and 0. Now this is the node, and what is this int? This int is the index given by its parent. For example, if it was 7, if its parent was 7, so its parent will give him as 7 into 2 14. Okay, and the right children will be given 7 into 2 plus 1 15. So in that case it will be 14 and 15. Okay, then later on we have to subtract it. Where we are subtracting, we will be then what we will do is, first of all I will do lx minus r in this while loop. For every level, this for loop will run for every level, check every level, and lx is int maximum, rx is int minimum, leftmost, rightmost, found. Then I am doing minus. What is this minus? As I told that I want it to be 14, I want it to be 0. I don't want it to be 15, I want it to be 1. I want to subtract the smallest index in that level, so that it becomes 0 and 1, so that the range is easier to handle. the numbers are easier to handle with int. So I am doing minus, which means front, or the first node of that level, and second basically means uh, its index. Okay, its index. And the for loop, this for loop is doing, means taking out the node, then it's taking out, okay, this is the node, and I am subtracting minus here itself. Okay, this step is important. Subtract the minus here itself and then add it to x. So that subtract 14 from 14 and then add it to x. Don't do it like first I will do 14 and then I will do x minus equals to 14. Okay, so here only do 14 minus 14 and directly store x is equals to 0 in it. Okay, and lxrx, so that I know the maximum and the minimum range. And what I will do in the end, I will do rx minus lx plus 1, so that I know clmw, which basically means current level max width is this much. So I will keep on updating my current level max width. So I will return my current level max width. So I think this question is also, you will be able to understand this question once you try to do a dry run of this question. Just try to do this question on your own, and what are the points which you need to take care of. You need to know why I am writing, why I am doing this. Okay, why am I doing this part. This is very important, very important part. And doing minus, this is very important part. So if you know these steps, then the rest part is same as level order traversal. So I hope you understood this question. If you did, then please like the video. You can share it with your friends if you want to. And I will see you in the next one. Oh yeah, don't forget to subscribe also.